Okay, so let's go ahead and get started. Go ahead and get set up. Not really a lot in the way of announcements. Just keep in mind that you've got this assignment done. I think a fair number of people have gotten this completed. Would it help anybody to have another example similar to the assignment? Or do you think the example from last week was enough? Okay, so I'll just stick with that. What I try to do is for every assignment, I try to have something that's like kind of similar, but at some point it gets like a little bit difficult to keep on coming up with similar examples. So it takes the pressure off me. Okay, so the example from last week was good enough. I'll leave you a little bit of time at the end of class to finish this. Maybe not as much as last time. Maybe, I don't know. We'll see how we do. Everyone took their midterm, right? Nobody's on it. Okay. What else do we have? I think that's pretty much it. So I guess we can just go ahead and get started. Any questions before we get started? Did anybody check out the videos from Microsoft to see if they were any good? Okay. Like I said, I don't know if they're any good. I zipped through them. It seems like pretty standard stuff. It's not like they're putting some new angle on it. I guess the only bit is that it comes from Microsoft, so at least they put some effort into making sure the information is probably correct. They probably didn't just put garbage out there. Unfortunately, sometimes with these, I've seen this a lot, and it's annoying that in the programming community, there's been a lot of these videos where, good example is there's a web framework called Angular. I don't know if anybody's ever heard of it. It's from Google. And it's very, very popular. And so what people do is that they put out these Angular videos that are very surface level and almost useless. A lot of intro videos, but they're very well produced, and they have like cool intro music, and like they're all, you know, the actual production is very high quality. It's just the actual material is so basic it's almost useless. And so I've seen a lot of those videos. I don't know if anybody else in here has noticed that trend on YouTube, is that there's a lot more lower quality content. But what's interesting about this Microsoft is that it's pretty complete. So.
Similar problem with Electron. I've been trying. I believe like a couple of years, I was trying to learn how to make an Electron app, and tutorials were so general, I couldn't figure out how to
Do real world stuff, yeah.
my own app.
Yeah, I've run into that. And they do it for the clicks, and nothing against them. They're trying to make a living, you know. They're target, but
This was from like, I think the tutorial that I stumbled upon was from the official like Electron.
really,
Yeah,
that's
like,
interesting.
I was just trying to learn, and I was trying to figure it out, and I was trying to figure out their libraries, and I was too young and dumb to figure out that it was all like node-based and NPM.
Yeah,
I mean, that's when I learned I didn't like JavaScript.
yeah. The new versions of JavaScript actually aren't so terrible. I used to hate JavaScript too. At some point, they actually renamed it. It's actually technically no longer called JavaScript. It's called EMSAscript. And so they'll abbreviate it to ES. And so now they actually have versions. And so ES6 and forward is way, way better. It's actually much closer to Java, the language, than it is JavaScript, the old terrible language. But now they have one even better. It's from Microsoft. It's called TypeScript. And you can actually now have typing information. You can declare variables with a type, and your functions can take in typed variables and return things, and class constructors and stuff like that. So it's a pretty good language. But anyway, we're here for Python, so I'll try to keep us focused today. Let's go ahead and open up a new REPL. Resources. So we have two major things still to tackle in the course. One is I really want to make sure everyone is solid on very complex data structures. Remember I showed you the Twitter API response before? Now I'm not going to give you an assignment, a new assignment. You know, you already have this assignment number or whatever that was, the one with the like the directory listing. So that's as complicated as you're going to get for an assignment. I do want to do something a little bit more complex, because a lot of people in here, you're going to go on to use one of these APIs, the Facebook API, the Twitter API. They're all relative, like these data structures that they send back tend to be kind of complex. So I want to do a slightly more complex example in class today, just to show you, just get some more practice. Obviously, like I said, I'm not going to give you a new assignment, but I just want to give you some practice, because these are what these data structures look like in the real world. So I want you to get used to dictionaries within dictionaries, and then that dictionary contains a list, and then that list contains a list of dictionaries, that sort of thing. So, okay, so let's go ahead and get started. So I'm working on a SCADA app for as part of a project here at IRSC that we're working on, and one of the data representations I'm using is JSON. That way it's like human readable. Part of it is that it needs to be like kind of as an educational resource. And so in the real world, I might use something that's like a binary data structure, like Google's, I can't remember what theirs is called, protobufs or something like that. But anyway, if you remember, I told you this JSON data format, which that's what this technically is. It stands for JavaScript Object Notation. This actually maps directly with dictionaries and lists. So this is perfect. It's like a one-to-one mapping. So you can take these data structures that are passed to you from these different web APIs, and then you can there's literally a library called JSON, and you can actually take that and convert it into in dictionary and lists and stuff like that. So, but I want to give you an example of a data structure that I created to give you an example of a real-world data structure and how you'd parse it. Okay, so say for example we've got a data response. And so for those that don't know, SCADA is basically this idea that, so it's actually for the solar field. How many people have seen next to the Brown Center the solar field we have? Okay, so it's actually related to that. And so let's think of the different types of data we would get from that. So it has, I don't know if that particular field, I don't think it has batteries attached, but let's pretend that it does. So a battery is going to have some sort of voltage. So there's going to be some batteries attached, and those are going to have a voltage. Those are going to have, at the time, they might have a charge level. They might have, if they're being used, how much current is passing through. Then we also might have how much the actual voltage of the solar panels and how much those are giving and so forth. So let's try to keep it simple. But that's basically what we're modeling. That's what a SCADA system does, is it reads those values and displays them to a user. But let's pretend we're just working on the data part. So all that equipment out there, the panels, the battery, any sensors or anything, they're attached to a controller of some sort. And you can think, you don't have to get overly technical. You can just think, imagine if they're all connected to a Raspberry Pi. Think about it like that, okay? Because it doesn't have to be like an industrial controller. It could just be flat out just a plain old Raspberry Pi. And so you might have multiple Raspberry Pis out there, so you probably want to give them some sort of ID or address. So let's start off with that this is going to be a data point returned from our Raspberry Pi. And so we want to know the ID of that device. And so maybe we could call it controller address. Let's do this. We'll do controller dash address. Let's try to mimic so these underscores. Okay, so we'll use underscores. We'll try to mimic their Twitter API. So the controller address. Because we want to, this is like data that the controller sent to us. We requested the current state of the system. And we might want to just be very generic and say, okay, let's pretend that a Raspberry Pi is our controller. We'll just call it Pi 1. And now a very common thing is that in the real world, over time, data formats can evolve. So it's not like I'm just going to define this data format once, because in a few years, we might upgrade our equipment, and not only does it allow us to get current and voltage, maybe it allows us to get irradiance or all kinds of other fancy things. And so we want to usually define a version of this data packet. Okay, so let's say version, and this is just going to be version 1. So this is, you can almost think of this as like the header. We want to know what controller it's coming from, and then the actual version of the data that we're expecting. Now it's going to send us back a bunch of data. It might send us back the data from a battery, from a panel, and so forth. So we usually call those data points. Okay, so let's make a field here called points. Well, points itself is also going to be a dictionary. Because then each point, let's do this. Let's do it as a list. It might make our life a little bit easier. So rather than dictionary, let's do this as a list. But this is going to be a list of dictionaries. Does that make sense? So we're going to have multiple points, and it's going to be a list of dictionaries. And each dictionary is going to contain the name of the point. And so let's keep our life simple for now. And the name, let's just say it's battery 1, or bat 1. What's it complaining about? I'm pretty sure that's a valid. Oh, does anybody see what I forgot? Comma. Yeah. So make sure to add that comma. So this is going to be the name, or maybe we can even call it address. That might be better. Let's do that. Let's call it address. Address sort of implies that we need it to be unique. And so on this Raspberry Pi controller, we can only have one bat 1. And then this battery is going to have, let's say, volts or voltage or V. And let's just give it something that's so a 12 volt battery is very rarely actually 12 volts. It's usually 12 and something like that. That's fine. Now, it's not uncommon to have multiple batteries. We might have bat 1, bat 2, bat 3, but we also might have panel 1, panel 2, panel 3. We might have other sensors on there, like a weather station or something like that. So let's do this. Let's say point type and this is going to be a battery. This may be a little bit out of order. It turns out the ordering of dictionaries doesn't really particularly matter. If I had to redo this, I would have probably put this at the top and put volts at the bottom, but that's fine, whatever. Oh, and then we need a comma between these. And then let's say we have our second battery, and just to make life a little bit easier, I'm just going to copy and paste. So we're going to have bat 1, and then this will be battery 2. It'll also be of type battery, and let's just change it a little bit. So this one will be like a little bit below 12 volts. And then maybe we've also got like a weather station out there controlled to it. I don't want this to get too out of hand, so this will be the last thing. And then the address of that weather station, we'll just call it weather 1. In practice, we probably wouldn't have multiple weather stations, but this is not uncommon, by the way. If you've got a bunch of devices that are otherwise the exact same, like if I've got like 5 batteries out there, I'd probably just label it bat 1, bat 2, bat 3, bat 4, bat 5, and then label them on the actual physical devices. And let's say this is sending us the current temperature. Now I could say, like, for example, the current temperature is 78 degrees. How do you think I could take that one step further? What do you think that's a little bit vague about just the number 78? Yeah, exactly. So now here we can have another dictionary where the temperature has unit. And here we say it's in Fahrenheit. And then value is going to be 78.2. This tends to much more look like a real-world data structure that you'd see. And even this is maybe a little bit oversimplified. Okay, so before we get started, first of all, let's make sure this actually compiles, that everyone typed it correctly. So if you run it, you should just get no compilation errors. If you do, make sure that you've got your commas in the right spot. This editor is pretty good about telling you the general location of where your issues are. So let's just do some exercises on this. If I wanted to print the voltage of all the batteries, so first of all, if I'm going through this, what does that imply? A loop, correct? So I have to have some sort of loop. what am I going to loop over? Am I going to loop over the controller address, the version, points? Of those three, which do you think I'm most likely to loop over? Points. And why do you, so that is the right answer, and why do you say points?
That's the only thing that has multiple dictionaries.
Exactly, yeah, so it's a list, and so it kind of lends itself to being looped over like that. It's the only thing that has multiple, like these are just key value pairs. There's really no point in looping over this. This actually has multiple points. And we don't know ahead of time necessarily how many points. This data reading that we take, this could return 50 different things. You know, it could have returned a bunch of battery readings and a bunch of solar data and a bunch of weather data and uptime information and maintenance logs or something. You know, those sorts of things. So let's do this. For point in we did miss one thing. I hate going back and changing things. What also might be a useful piece of information here that I forgot? What do we have under battery that we don't have here? We probably also want to say the point type. So do a comma. I apologize for that. And to me, let's just say the point type is just going to be weather. So for point in, what am I going to loop over? We already said points. How do I access points? What do I type right here where my cursor is? For point in, so data, square brackets, and then what? Points in quotes. Perfect. And when we're assembling these things, a lot of times it's just a good idea just to just do something like this, just print point. This isn't the thing we're trying to accomplish just yet, but we get stuff back, so we think it's working. So let's think about this. What if I wanted to see all the voltages for batteries? What could I do? So I'm looping over everything. Yeah, correct, yeah. A list of dictionaries.
I got confused. Was that you had to label each element of the dictionary.
Yeah. Okay, so if I wanted to access volt, how would I do that? I would go data, points, and then, so we already have data points. So right now, I'm here. So that's what point is. Point is going to return that little dictionary. How would I access volts?
Another for loop.
So we could do another for loop, but that's probably not, if we know the thing ahead of time that we're trying to access, we probably actually don't need a secondary for loop.
So we can do if point square brackets volts
Perfect. Well, so not,
equals,
so we might want to do something like this. First of all, because every single point isn't going to have volts, maybe we want to say if point type equals battery. And now this is great because this is only going to, during this iteration, we know that it's a battery. We've sort of guaranteed that it's going to have volts. What's that? Exactly. So at this point, we know it's a battery. If we didn't have this, what would happen is that we would try to access volts here, which we see doesn't exist. And so we would get a key error. So then from there, we can print point, and then what? So right here, or here, we're inside the dictionary. How do I access the volts? What do I put in the square brackets? I just put in volts here. Because we're in this dictionary, and then we've got our 3 keys here, and I can just directly access volts. And we can even be a little bit fancier. We can say, we'll print the address and the volts. So I run this and I see that battery 1 has this voltage, battery 2 has this voltage. So let's do this. Let me leave this as an exercise to you, and then we'll go over the answer in a second. What if I wanted to print the temperature in Fahrenheit? Okay, so take about 5 minutes and try to work through that on your own. You can leave it within the same for loop. You don't have to create a new for loop. And the goal is to print this right here, and to also let the user know that it's in Fahrenheit. So take 5 or 10 minutes to work through it. It's one of those things, even if you don't get the answer, just the thought process, going through that, and then once you see the answer, it's like, okay, that's it. Rather than if I just give you the answer, I'm just giving you the answer. It's not really worthwhile. Okay, anyone want to try to walk me through the answer here? So what's the first obvious thing I have to do? I'm not checking to see if it's a battery. What am I checking to see if?
It's weather.
Perfect. So we'd say if the point type is weather, and then we know it's going to have an address. So just so we know the address. Now here's the hard part. How do I actually print that value, and how do I get like? So let's say for how do I access this right here, this key value? So we know it's going to be point something. So that means point, that means I'm here. Perfect. So the next thing we're going to access is temp for temperature. And then that's going to give us this. So then what would we have to do? Yeah, and so what happens is this is going to return a dictionary. And so what we do is we just put square brackets next to it. And then that's going to give us the value. And what we can do is just for printing purposes, it's not uncommon for these very complex, this one's not too complex, but this gets a little bit tough to put inside an F string. So sometimes what I'll do is I'll kind of alias it and say, okay, that this is going to be the value. And then unit, walk me through that one. Should be very similar.
And it is just the same thing, but for values.
Exactly, yeah. And then now we can print and then it's going to be value unit. Now I want to do one more thing because I don't want you to think that this is how every single JSON data structure is, because a lot of times you can take the same problem and structure it. I shouldn't even say, well, it kind of is JSON, but you can take the same problem and structure it a bunch of different ways. So what I want to do down here is basically, let's do this. Let's start as a new example. This one's getting a little bit busy. A little too much on here. Let's take that same data structure data equals, there we go. And so we're going to keep this the same. We're going to, the controller address and the version, we still want that. And we still want points to be a list. Oops, sorry. Has to be in quotes. By the way, you don't always have to use strings here, but the vast majority of the time you will. The only requirement is that it has to be something called, it has to be immutable, meaning unchanging. But in practice, like a pretty good chunk of the time, it's going to be strings. The reason being is because strings are like easy to like type in and access versus other data types. Some might not necessarily be like if you try to put an object in here or something like that, it doesn't really work out that well a lot. So the bulk of the time, this is going to be just a string. And we can say, okay, well, I don't really like having these if statements in here. Maybe another way to structure this is within points that I'm going to have. Actually, so points is no longer going to be a list. I apologize for that. So points is now going to be a dictionary. And then what we're going to do here, so this will be our batteries. I should have probably early on decided to use the full word battery, but I have to deal with my mistake now, so it's always going to be bat. That's actually the reason I do that. If you ever work in electronics, that's not uncommon for them to use this abbreviation in software. But anyway. And then what data type do you think this is going to be? Any guesses? There's only two choices. It's either a dictionary or a list. Which do you think it's going to be? List. And the basic idea is that now we can do away with this point type. So I'm going to save a little bit of time here and copy and paste. Because we already know the point type. Does that make sense? Because it's in this battery list, we know that it's a battery. Let's make a little bit of effort on formatting this, I guess. And then now what I want you to do is the same thing for the weather. So take a few minutes and then try to bring over weather and do the same thing. Now think, even though we only have one weather station, do you think it still makes sense to put it in a list even though we only have one? Yes or no? Who says yes? Who says no? There's no opinion. Okay. The answer is yes, because even though we only have one weather reading right now, we could have more. And it's very probable that we would have more. So let's keep that in the list. Because we could potentially have more weather stations. It also sort of keeps it symmetric. Sometimes it's kind of weird when you've got like a list of batteries, but then the next thing is just like a key value pair. Okay, so all we would have to do is after bats, add a comma. I usually like to make my lists plural, but sometimes the plural version doesn't really make sense. So if our weather data singular is weather, what would be the plural? Weathers, which is a little bit awkward, but let's go with it. Did anybody come up with a better name than that?
Names, weather names.
Yeah, that too. We'll stick with this since I already typed it. Oops. Did I already put that? And I don't need the point type, I just want the address.
Want that to be a list?
Sorry, yeah. I'm already messing up my own example. Thank you. Bonus point. So this may seem complicated, but the fact that we built it from the ground up, I mean, it's still probably complicated for a lot of people in here, but knowing that process that we went through, if I were to just showed you this at the beginning of class, it'd probably be difficult to read, but when you really go through it, and it kind of makes sense why we structured it this way. It's like, okay, well, this data is going to be coming from a controller. That controller might be sending multiple versions of the data, or maybe not that controller, but our controllers in general. So we want to know which version of the data it's sending because it might restructure the data a little bit. So the very first thing a lot of times with JSON is that or dictionaries, they'll offer like a version, and you'll say, okay, if version 1 parse it this way, if version 2 parse it a different way. But then we've got our points, and we know that we're going to have a bunch of data points. These are going to be basically sensor readings. And the first way we kind of left it as a little bit more of a flat structure, and we added a field in there called type. But here what we said is, okay, instead of that, let's make type its own key, and then it's going to have a list of things. If I were designing this in the real world, I would probably say my preference would be for the first way. In general, I like to usually have like a type field that I can access. This becomes a little bit more complicated because what you have to do is you have to return all the keys, and then you have to cycle through the keys. I kind of like just having a field called type or something like that. That makes it a little bit flatter as well. But I'm sure there could be arguments for both. I'm sure if we went on Stack Overflow right now and said which is better, we'd get probably 30 different responses arguing. How many people go to there for, it's a question answer site. How many people have seen that before? Stack Exchange. The network is called Stack Exchange, but mostly the programming was Stack Overflow. And you probably see lots of arguments on the best way to do things, right? Yeah, that's pretty common.
But at least it has some answers.
Yeah, exactly. Yeah, it's actually, I would say one of the best things that happened to the open source community was the creation of that site, because there were a lot of open source libraries and open source projects that were very difficult to use and poorly documented, and it basically kind of gave everybody a place to say, hey, this is a problem I had with the software. You used to kind of have to resort to mailing lists and maybe you'd get an answer, but Stack Overflow really put everybody in the same kind of community all at once rather than a bunch of mailing lists that were spread out. And then once it was documented, that combined with search engines made life a lot easier. So definitely helped. Now apparently there's all kinds of internal feuding, like any project that's been around for a long time. It gets complicated. Now that's all kinds of random stuff. I'll see on the side it'll like offer, there'll be questions about like Dungeons and Dragons rules and stuff like that. All kinds of, but the core of it was typically programming, and especially the open source community. Mm-hmm.
I made 3 mistakes. I was trying to build a game engine off of a YouTube video.
Yeah.
I then ran into a problem, and I asked Stack Overflow to help me.
Yeah.
And I submitted a screenshot of my code rather
Yeah.
than text. And people got very, very annoyed
That is one of the problems with that goes all the way back to the 80s, is that like the tech community is very short with people, and it's not necessarily that they're mean, it's that they're very short, which often comes across as being very mean.
Well, I understand why all three of those things were a mistake.
Yeah.
Back then, it was so new.
It's almost like they need, you know how like a lot of games now they'll have like a tutorial at the beginning? They should have that, like where you post fake questions and you know, to get you trained.
Get your programs like Stack Overflow.
Yeah.
That'll be a Stack Overflow.
Hey,
That's something.
you know what? You could write that in Python, and maybe that wouldn't be a bad idea for somebody in here to do. So, anyway, okay. So let's take that last little bit that we need to do. We'll keep it simple. Let's just print the battery information.
Oh, and I also got my thread muted, I think, by one of the moderators.
Was it off topic or something? Was it like a?
No, it was just because of all the things that I did, I messed up.
Oh.
I messed up, so the moderator just looked at it and was like, yeah, this is not a valid question.
I don't necessarily agree with that, but it's like Wikipedia, where it's like you've got these people that are very overly passionate about online things. You know, be passionate about the real world. Sometimes you got to step away from the online world, but and so they kind of treat that as their baby, and sometimes they'll be a little bit harsh for no reason. Okay, so if I want to get the individual batteries, I do for bat n, and then I navigated through here. I went to data, then to points, then bats, which is great because that's going to return a list. And then since I know each one's going to be a battery, I can just print bat volts. Now looking at this, the one design change I might make to this, just to keep it kind of consistent and symmetric with weather, is that it is actually very common to have a value and a unit. Here I just said volts. I've never heard of another unit for expressing voltage, because it's actually called voltage potential. But there could be, or maybe you could be returning it in like microvolts or millivolts or something like that, and that might not necessarily be clear. So an extension is that you may want to convert that volts into something like this, where the value is the voltage and the unit just could be in, you know, something like that. But it's also very easy to get into over-engineering as well, which I've run into myself doing many times. So sometimes you might want to just keep simple things simple. Okay. This is obviously much more involved than your assignment. I just wanted to give you practice because, like I said, this is still relatively simple compared to the Twitter API. You know, like, but now you should be able to be a little bit better at navigating this. It's like, so you get back the result, and then you've got this field here called entities, which is a dictionary, and then hashtags, which is a list, but it's an empty list. So let's actually, I was going to go over object-oriented programming, but I think it's better to spend a few minutes on this, and then we'll just start object-oriented programming Monday. Let's go through this. So this is the result of a single tweet. Now, this is technically not dictionaries and lists, but like I said, there's a one-to-one mapping. So technically, this is a data structure called JSON. But so let's go through this. Now, a tweet, I don't use Twitter myself, but I guess I know enough about it that I can kind of parse this. So the text would be the actual tweet. The created at, that would be the date that they created at. Now user gets a little bit complicated because not only, so every user is going to have a unique ID, like a numeric ID, which makes it easier to track. In general, when you're working with database type stuff and data structures, a lot of times you give it a unique ID. It makes it a lot easier to trace down than like a screen name. So we've got a unique ID. We've got the person's name, their screen name, and so on. Okay, so that's pretty straightforward. And there's only going to be one user that made that tweet. So that makes sense. The place, that's going to be a dictionary with probably like latitude and longitude or something like that, but that happens to be empty. And then we've got this field called entities, which is very vague and generic. And I think that's the whole purpose of entities, is just like, anyway, I don't want to get into it too much. But you can see here what data type is hashtags. I know it's kind of tough. Let me really make this large here. So what is hashtags? A dictionary or a list? And explain why it makes sense as a list. Because a tweet can have multiple hashtags, correct?
Yeah.
So you just have a list of hashtags. That would make sense. And then somebody might reference multiple URLs. Like they might link to multiple like sites. I don't think it's common, but it's possible. So you want to also have that as a list. But then it's going to be kind of, there's a little bit more to it. It's not just the URL itself. We have the URL, and then I think Twitter has a URL shortening service. So that's not the actual original URL. So here, this gives you the original URL, and then the actual title of it, and so on. So unpacking this, you can see that just probably the first time I showed you this, like a couple of classes ago, this probably seemed extremely complex. But once you really start to walk through it, now you think in your head, okay, I've got these entities. I want to see all the hashtags. I'm probably going to have to loop through the hashtags. So I'm going to have to do tweet, and then in braces, entities, and then I'm going to loop, and then I'm going to get in braces again, hashtags. So I might do for hashtag in tweet, entities, hashtags, and loop over that, and then just print all the hashtags. So you get the idea, okay? So let's do this. I was going to start object-oriented programming, but let's as just kind of an informal homework assignment. I think I give you some links under resources. Let's start with this one. We have, oh, oops, I don't want to bookmark that. So under learnpython.org, which is linked here, it's the very first link, start to look over classes and objects. And just maybe just very briefly read this, just so you can get a sense of it. Now I will tell you, so in the 80s and 90s, object-oriented programming languages became very popular. So just to give you an example, even if you don't know what that is, languages like Java, which most people in here have probably heard of, C#, C++. A lot of these languages relied very heavily on this programming model called object-oriented programming. The basic idea is that it's supposed to model the real world. Java really takes it to an extreme where essentially you can't write any code without it being an object. It makes your code highly organized, but we run into that problem again of over-engineering. Simple things aren't simple. It's like everything, if you've got this very complex model, it can handle everything, but doing simple things isn't necessarily simple. Python takes a little bit more of a hybrid approach. You can still do object-oriented programming, and oftentimes people do, but a lot of times you'll realize that, hey, well, that thing that I might have written in Java as a bunch of classes and object-oriented programming, I can do the same thing in Python with a dictionary and a few lists. Okay, so in a language like Java, if anybody knows Java, pretty much everything that you're dealing with is like object or class or something related to that world. In Python, it's not leaned on so heavily. So we are going to learn how to do object-oriented programming in Python. It is used, but in reality, you'll find yourself using modules. Remember, we talked about modules. You'll find yourself using modules a lot, modules with functions, dictionaries, and lists, probably just as often. Okay. In the Java world, you tend not to use those types of things as often. You tend to rely a lot on classes and objects. Okay. So, but that's what we're going to start spending our time on. We'll probably spend a week or two on that. And then once we reach that point in the course, then we'll probably start to, that'll be like a good foundation. And then from there, that takes us into like the last basically month of the course roughly. And then from there, we'll start to learn real world libraries. Like I told you, there's these cybersecurity libraries and so on, okay? So any questions? So just a few minutes to work on your assignment, just enough time, I guess, to answer any questions if somebody runs into a problem. If you finish the assignment, you don't have to stick around. You can head out, which I think accounts for a lot of people. And if you head out, I'll see you on Monday. Email me if you have any problems. Otherwise, for everyone else, just hang out and work on your assignment, and I'll answer questions. Okay?